Goodbye, Cassini, your mission's fini. Bravo, Cassini, have some linguini. You showed us Saturn's rings and lots of pretty things. Huygens probe took a dive early 2005. Landed on Titan, it was exciting. Your mission never failed to surprise. Dazzled our eyes. Now dive to Saturn, vaporize.
In 1997, an ambitious international mission launches to Saturn that would, for the first time, attempt to place an orbiting spacecraft around the planet and land a probe on a moon in the outer solar system. But it was a mission that had to fight its way just to reach the launch pad.
Our Congress has had some agony over the program. We're going to have to operate under a very strict fund ceiling and an unyielding schedule.
We are all going to have to strive for, as we go through this process, is a continual search for the least unacceptable solution.
The journey to Saturn took 7 long years, and being captured into orbit depended on what would happen during just 3 hours.
We chased everything that could go wrong down the rabbit hole. We went down every path of, if this goes wrong, what do we do? If that goes wrong, what do we do?
All stations on that, SOI systems. Just an advisory, we're coming up on the time that the critical sequence will initiate the turn to the SOI burn attitude.
This was one of those moments where you're either in orbit or you're a billion-dollar flyby.
Flight, SOI-Com.
Go ahead, SOI-Com.
The Doppler has flattened out.
With Cassini safely in orbit, science quickly took center stage, beginning with dazzling images of Saturn's rings.
I'm surprised at how surprised I am at the beauty and the clarity of these images. They are shocking to me.
Investigating Saturn's iconic rings will be just one part of what will turn out to be 13 years of discoveries about the Saturnian system. And what will be realized about Saturn's moons will even transform how we think about our solar system and open up new pathways for the future of space exploration.
Around one planet, we find 2 moons that could potentially have the key ingredients to support life.
Triumph at Saturn. Next. For some scientists, the Saturnian moon Titan has been a higher priority for exploration than even Saturn or any other planet. That's because Titan may resemble what Earth was like billions of years ago, making this moon a kind of time machine that preserves in deep freeze many of the conditions that led to life on our planet. Titan is the only moon in our solar system having a dense atmosphere made mostly of nitrogen, just like the Earth. There are smaller amounts of methane and ethane that break down into organic compounds, creating the moon's smoggy orange haze. Titan's extremely cold temperatures turn some gases into liquids, which led scientists to wonder, could Titan have oceans, made not of water, but of liquid methane and ethane? These questions made the unmasking of Titan a major objective of the Cassini-Huygens mission. And before the release of the Huygens probe, Cassini would have the first opportunity to see this moon close up. With hopes sky high that the spacecraft might see Titan's surface, scientists were eager to share the 5-hour-plus flyby live with the world.
And you're watching live coverage from the Jet Propulsion Laboratory in Pasadena, California. Tonight, the Cassini spacecraft has its first close encounter with Saturn's largest and most intriguing moon, Titan. This is the closest we have ever been to Titan, and over the next 5.5 hours, we hope to see the best images we have ever seen of Titan. And here on NASA TV, you will see those images just minutes after they actually arrive on the ground.
And right on cue, the images began streaming down. But it quickly became apparent that Titan wasn't ready for its first close-up.
We have just received exciting word that we have the first image in.
Okay, so this looks like, boy, it takes a bit of processing to bring out features.
What appeared at first glance to be black and white smudges left scientists and viewers alike puzzled as to what they were seeing.
Look at that. Look at that. And we don't know what it is.
Anything stand out in your mind at this point?
Yeah, it's been a very strange evening. If you put me against a wall and said what's cloud and what isn't cloud, I really couldn't tell you. I assume that much of this is surface features. Yeah, these are low contrast, not really sure what we're looking at here.
With us now is Torrance Johnson, one of the imaging scientists, to kind of give us the overall, what does it mean?
Well, I think first off, the main thing that tonight's meant for us is we've had a very successful encounter. We're really looking at a great haul of data here. And well, you saw some of this stuff coming in. There's clearly stuff to be seen there on that surface. Understanding it's a different issue. And one of the things that all of us on the project have been talking about for a long time is this sort of cooperative science approach. We knew Titan was a tough target, was going to hold its secrets tightly, and so we designed this mission and the experiments to hit it with everything we've got. And this is our first chance to do that, really. We're really going to have to do a full-up, complete body scan of Titan to figure out what's going on.
This encounter confirmed that Titan would be as complex as it was obscure. Fortunately, there are many more Cassini flybys still ahead. But next up to explore Titan is the European Space Agency's Huygens probe that will try to descend all the way to the moon's surface.
The procedure here is pretty standard. We're going to follow right through the MOP. The idea is a series of brief reports from
8 weeks have passed, and it is the eve of Christmas Eve as leaders of the Cassini-Huygens team hold a go, no-go meeting on whether to release the Huygens probe.
We had 2 opportunities to update this, one at the Titan flyby.
There are no known technical issues with which to contend, making this meeting mostly a formality.
And cleanup. Navigation has flown a precision trajectory, so there was no need for us to make any updates.
Tracking data has been absolutely excellent lately. The DSN has been doing a really good job, and Julie's team has doing a marvelous job. She has given us recently really great maneuvers, so without that...
Yeah, don't jinx it, Jerry. Don't jinx it.
I'm just raising my expectations.
There go the pagers.
I know, yeah. Because I jump because the pager goes off.
Based on what we've heard here from the representatives of the people that did the work, it's very clear that the orbiter JPL part of this team is ready to proceed.
The probe team is also ready to go, so we are green for tomorrow. So let's go.
Okay, well, let me just add my enormous thanks from the European side for the terrific collaborative effort on the US side. It's just been great to be working with you, and I think we're all very appreciative, and so let's go.
Okay, we are a go. Very good.
Southwood's remarks were heartfelt. As 4 years earlier, the mission had faced what seemed an unsolvable problem, a design flaw found on Huygens' receiver located on the Cassini spacecraft. An in-flight test revealed the receiver was incapable of adjusting to Doppler shifts changes in radio frequencies. That would leave Huygens' data nearly worthless. A major fix required a hands-on solution. Impossible to do with the probe a billion miles away. Knowing little could be done to Huygens, the best hope rested with Cassini, when mission planners realized that adjustments to the spacecraft's trajectory could minimize radio frequency changes. This required Cassini to fly higher above Titan and at a relatively slower speed, which would allow the data to be accurately recorded as the probe descended. But this solution was not free. It would cost Cassini a quarter of its reserve fuel. This sacrifice confirmed that Cassini-Huygens was truly an international partnership, for without this decision, Huygens was assured of being seen as a failed mission. The crisis was now only a memory, and it was now time for the probe to detach from Cassini to begin its dangerous descent into Titan.
Flight director, we're going to do a final pull here.
There's a JPL saying that for some celestial reason, major mission events always seem to happen on holidays, weekends, late at night, or a combination of the three. The probe's release is no exception to the rule. It is Christmas Eve.
I'd like to start the poll in 5 minutes.
On hand to show their support for the Cassini team are leaders of the Huygens probe, JPL Director Charles Alachi, Caltech President David Baltimore, and arriving just in the nick of time, JPL veteran Tom Gavin, whose job title includes the phrase, Mission Success.
Nothing like cutting it close.
Nothing, well,
Or you lost signal.
Well, I knew you had under control. Right?
Yes, sir.
He came for when we received the signal. That's the important thing.
Got it all.
When will they acquire the signal, do you think?
Earliest carrier lock is 729.
That's right on the money.
Right on the spot.
It's like exactly.
Released. All three. All right.
We see a big...
Okay, you're on your own now, you know.
With the Huygens probe now on its own, silently free-falling to Titan for the next 21 days, the Cassini team can relax and enjoy the holidays, especially New Year's Day. That was because JPL was sponsoring a float in the Pasadena Tournament of Roses parade for only the 3rd time in the lab's history. The float featured 9 JPL missions. The one at the top was Cassini. The Huygens dive into Titan is the most distant landing ever attempted. The descent through the atmosphere is expected to take more than 2 hours. The hope is that the probe's batteries will last long enough to reach the surface. What it will be like, no one really knows. Because there could be lakes or seas of methane, the probe has been designed to float. But first, Huygens has to survive the plunge through Titan's atmosphere. The entry speed is more than 12,000 miles per hour. Soon, temperatures are soaring over 3,000 degrees Fahrenheit. If the heat shield does its job, the science instruments inside the probe will have no idea there is an inferno taking place just inches away. After surviving the initial phase of the descent, the first of 3 parachutes deploys. Nearer the surface, the winds begin to calm, and Titan's orange haze begins to clear, revealing below a surreal landscape.
So imagine descending down through a misty, cloudy atmosphere, and suddenly below you breaks this vista of this very bright hill with channels that are carved by liquid, with rounded pebbles that were evidently rolled and tumbled by liquid. That was what the Huygens probe saw, and it showed us that methane not only is in the atmosphere, but has been raining and producing weather and carving features in the landscape for long periods of time.
As Huygens lands in a triumphant plop, history is made. And better yet, the probe's batteries are still working. What Huygens sees seems to resemble a dried-up riverbed. Right in front are rocks made of frozen water, harder than stone. There are no signs of lakes or seas. But Huygens' view is only a single spot on a moon larger than the planet Mercury. The global reconnaissance will come from Cassini. On many of Cassini's orbits around Saturn, the spacecraft will fly near Titan, allowing navigators to use the moon's mass to alter trajectories while at the same time conserving fuel. These flybys are also opportunities to use Cassini's powerful radar to penetrate through swaths of the moon's hazy atmosphere. The radio waves that bounce back from Titan's surface can be turned by scientists into topographical maps. Piece by piece, swath by swath, Titan is revealed.
Let's start at the beginning and run to the end and just see what interesting things we see, and maybe you could point out the things that you've seen too.
Okay, here's the new swath as it comes through here.
Titan really is, in some ways, a kind of a cosmic striptease act, because we can't see the surface in the normal wavelengths that our eyes would use, and the radar operates by making images in narrow strips, and so strip by strip in different places, Titan has been unveiled.
Here, can everyone see?
In that slide, you can see a feature that runs almost perpendicular to the altimetry track.
So we see the end of the dunes here, and you see the dunes peter out, and they get brighter, which is interesting here.
Massive dunes are seen, made not of sand, but of organic molecules containing carbon.
From the email traffic last night, I sort of gather nobody sees a magic island in the data that we have, correct?
I think that's correct.
I'll tell you what, you want to zoom in on the beginning of that?
A large dark basin turns out to be a lake full of methane. It is the first of hundreds of deep lakes and seas that will be found.
Most of the observation of this lake, they show a subsurface reflection. So the depth of this particular lake is about 100 meters, as we can see from the axis of the image.
Is it right to get out of this that the small lakes don't seem to be any shallower than the larger lakes?
Titan's strangest discovery is a continent-sized area named Xanadu. Here are canyons and mountains that resemble no other place on this moon. It is as if, one scientist said, it's from another world.
One thing, just to make a quick comment, is that
I am always very impressed by the radar planning teams. They absolutely got it right on the bullseye, because this is, you know, a long way away, flying by at kilometers per second, and they put it right on the bullseye. Nice job.
Titan may even have volcanoes that gush out an icy mixture of water and other materials. And this water comes from a hidden ocean beneath Titan's icy shell. And whenever water is mentioned, it's not long before the question is raised, is this a place that could possibly support life?
Giant Titan, the size of the planet Mercury, has a global liquid water ocean underneath its icy crust, as well as methane lakes and seas at the North Pole. And we wonder, could those methane lakes and seas support a different kind of life? So that's really opened our eyes.
There's still more that was discovered. This moon has weather and seasons. Here it rains, not water, but methane that floats down like snow.
It's so Earth-like that this is a very familiar place. The chemistry in the atmosphere is much more complex than expected, and the system as a whole is just as intricate as Earth in terms of the atmosphere interacting with the surface and the materials on the surface. Titan has a methane cycle just like Earth has a water cycle. And being able to watch that in action, seeing the lakes on the surface, the channels that have been carved into the surface, and then actually seeing clouds forming in the atmosphere and rain, the effect of rain on the surface. That whole cycle has been one of the things that's been absolutely spectacular.
Saturn's moon, Enceladus, was also a target of special interest for Cassini. It is the most reflective object in the entire solar system. And a great mystery was why this moon seemed to have so few craters. Theories abounded. Might there be some internal heat source that melts ice on the surface, which then fills in the holes? Could volcanoes or geysers account for the moon's shiny facade? Or was Enceladus just a dead, airless ball of ice? Cassini would find the answer, sending shock waves through the scientific community, all of it brought about by one of the spacecraft's least known science instruments, the spacecraft's magnetometer. It's a kind of high-tech compass that makes measurements of magnetic fields. It's so sensitive that it can even detect the spacecraft's own magnetic emissions. To cancel out those unwanted signals, this instrument was marooned out on the end of Cassini's long boom. On this flyby, no one was expecting there would be much from the lonely instrument.
I must confess we weren't expecting to see anything, and so we didn't look at the data for a couple of days. And then when we went in and looked at the data, only magnetometer people can get excited by our data, because you sort of plot it as on a scale where you look at the whole day. And we had a look at the wiggles on the plot, and they looked strange.
The expectation was that Saturn's magnetic field would extend straight out and flow directly through Enceladus. Instead, the magnetic field was curving around the moon. There were also unexpected signs of ionized water vapor molecules. These were measurements that could be translated into sounds as the spacecraft approached and departed from Enceladus.
And so it was clear that there was a source of water group ions in the vicinity of Enceladus. And in addition to that, there was something strange going on in the magnetic field. It looked as if Enceladus was a much bigger obstacle to the flow of plasma and field coming from Saturn. It was almost as if the magnetic field of Saturn and the plasma of Saturn were being stood off from the surface of the moon.
Unsure of the accuracy of the data, Dougherty and her team awaited the results of a second, closer flyby.
And I must confess, we looked at that data straight away. We were a little concerned about the calibration of the instrument, but that there seemed to be something in the data which was pointing to an atmospheric signature of some kind. And at that stage, we were talking about an atmosphere covering the entire surface.
Not everyone on Dougherty's team agreed. For one thing, tiny Enceladus lacks enough gravity to hold an atmosphere in place. In hopes of solving the mystery, Dougherty proposed flying even closer to Enceladus on the next flyby. Doing so would upset trajectory and science plans long ago mapped out, but Dougherty's argument won the day. Navigators plotted out a new course that sent Cassini skimming just over 100 miles above the moon.
For the couple of nights before that flyby, I didn't sleep. What happened if we had seen nothing at all? No one would ever have believed anything I said again. And I didn't sleep well at all. But then we got the data back, and it was spectacular.
In the southern polar region, Cassini found the landscape free of craters, yet littered with house-sized boulders of ice, carved out along bluish trenches that scientists dubbed tiger stripes. The moon would no longer be known for being smooth. Here was a fractured surface, containing crisscrossing faults, folds, and ridges. These crevices tell us that Enceladus is geologically alive. From these fissures, more than a mile deep, geysers are erupting. Nicknamed Cold Faithful, they are continuously spraying out massive jets of ice particles and water vapor. The speculation from more than a decade before that the shiny surface of Enceladus might be the result of ice volcanism turned out to be true. A momentous discovery that began with unusual wiggles on a chart.
I thought, okay, my reputation is saved. They're not going to think I'm crazy. But also, it made me feel really proud of what magnetometer instruments can do because, you know, in some ways, because we're just wiggly data on a plot, it's very hard to get people enthused by our data. You sort of media guys as well, it's really difficult to enthuse you.
The detection of geysers was stunning, for it meant the existence of liquid water near the surface of this bitterly cold moon. And that turned Enceladus in an instant into a prime target for the remainder of the mission. Previous plans were tossed aside in favor of adding more Enceladus flybys, including dramatic plunges through the plumes.
What is that? And look at this little thing here, this circular feature. It's so complex. The question is, are both of them coming out of the tiger stripes? Be nice to get a temperature measurement right on that. Look at that. It looks almost like a river. But see, that's in shadow, but we can still see because the moon is so bright. So there's so much multiple scattering.
Enceladus is as small as it is bright. This small when compared to Earth and our moon. Given its diminutive size, it was thought Enceladus would have long ago lost any interior heat. And what, scientists wondered, was causing Enceladus plumes to spray out these hot spots? The answer involves Saturn's massive tidal forces. They create friction inside the moon's interior, where there exists an ocean of water, a tremendous discovery. And liquid from this ocean wells upward, creating the moon's hotspots and the geysers that vent out. And from these plumes, scientists discovered that the moon's ocean contains salts and complex organic molecules, likely created by hydrothermal vents, the exact conditions believed to have given rise to life on Earth. For many, these discoveries about this tiny moon was Cassini's biggest triumph. For Enceladus is now one of the most promising destinations to search for life elsewhere in our solar system. Cassini's discoveries during the first 4 years at Saturn raised new questions to answer. With the spacecraft in excellent health, NASA twice extended the mission's funding. Over the course of 13 years, the spacecraft orbited Saturn 294 times. No two orbits were alike. Determining the pathways for these intricate loops is the work of true rocket scientists, or as they are called, tour designers. They are mathematical wizards who charted courses through the maze of Saturn's 80-plus moons and its ring system.
Tour should be ranked green if it's...
That is half of the job of these 3 tour designers. The other half, trying to please 200 scientists.
You know, this tour is probably a yellow, because I hate to keep having this email exchange back and forth. Looks bad, I think. We're taking in all the science requirements, which are, you know, can be a stack that thick. We're kind of like a tour guide bringing a big group of kids or scientists to Disneyland. And the only problem is we have to stick together as a group. We all have to do the same thing. And it's, again, trying to please everyone equally, or as my old supervisor said, equally unhappy. If everyone's equally unhappy by the end of the tour selection process, then we've done our job.
You can see that all of the tours have a large number of southern hemisphere coverage.
We have evaluated the nominal tours that came out last week. Any modifications are things that we're going to have to grapple with as a group this week. We can't have an input that's a mix of the two unless we all understand all of the implications.
Hey guys, can I interrupt for a minute?
They debate it out, they listen to each other, it gets heated at times.
Is that a reasonable approach?
That's what I would like to see.
But I have an objection to that.
Yes.
Are we making the right choice for the right reasons?
Well, every team is going to have to think about that, because we're not going to do the allocation until after the tour is selected. So in a sense, you are taking that risk.
It can be very frustrating at first, because in one meeting someone will say, well, do A, you got to do A. And the next meeting they'll say, oh, you can't do that, you have to do this instead.
Just a strategic comment. I think everybody in this room knows how rushed the evaluation of all these tours were, because they came in so late.
It starts out, everybody's on different ends, sometimes yelling, sometimes red-faced, really mad, like they're really trying to make sure they get heard.
The tour designers have been looking at what is the flexibility in a given tour to raise and lower the altitude. You know, we have to look at the ripple effect.
When you're up high, out of the orbit plane, you're up way above Saturn, you get a good view of the rings, but you're not around any of the other moons. And so the people that want to look at the rings want to be up high and look at the rings. The other people want to be down in the same plane with the rings where they can visit all the other moons. And that's a huge tug of war. You know, it's such that the J2 perturbations aren't maximized.
What you're hearing here, and I said it earlier, what you're hearing from people in this room, the science side, they haven't had a chance to really evaluate the information in a way well enough so they think we've got the right decision. And so I think
we had went through the stressful times earlier in the week, you know, meeting with each discipline working group, because, you know, we sit in front of these, you know, 40 or 50, you know, world-renowned scientists in a specific field, and it's kind of like a congressional hearing where they just fire off questions, you know, one after the other. you really have to know your stuff and understand every idiosyncrasy of each specific tour.
But after they got hurt, I mean, people kind of calmed down a little bit, but eventually everybody gets agreed, yeah, that's kind of the best thing. So we're very lucky that the spacecraft is very highly functional and we have a lot of fuel. All the tours are good, and I'd feel happy if any of them got selected. I mean, all of them are going to be really exciting. Just amazing pictures. It's almost like we have Ansel Adams riding on the spacecraft. I'm talking about pictures, but I mean, the other stuff is neat too. I mean, some of these instruments, they can just take a picture and they can tell you what it's made out of. It's like some sort of Star Trek thing, you know, but really Star Trek didn't have instruments this cool, you know? They just had this like green ray, you know, and it did everything, right? Their tricorder or whatever. Or the really amazing stuff is when they find something that's like, they have no idea. They have like a Iapetus, that ridge. Iapetus, it's like the equator is actually marked. It's like when I was a kid, I had a globe that got messed up and the equator kind of stuck out. I mean, that's the way Iapetus is. There's this mountain ridge right along the equator. It's so bizarre.
This meeting was only one of several taking place. It is at this larger gathering where the proposals of the tour designers, representing a year's worth of work with little time off for weekends and holidays, will be judged.
Compared to the usual agenda, today is turned upside down, and the reason for that is tour design is the main topic of this whole meeting. You'll notice that there's some filming or video going on. This is a JPL activity to document how decisions are made on projects and well, they go have a cutting and editing process, so I'm not sure that we'll recognize it necessarily when it's. In any case,
it's like the worst take-home final ever invented. You have 200 professors, you know, and the hardest questions you can think of, and you're just kind of slogging through it, trying to get it done, and then you hand it in. PF7, 11, they're both very much like 6 and 6H9. It kind of feels good to have it handed in, but you're not really awake enough for really much of emotion or anything. So you end up with a Titan flyby at apoapsis and or at periapsis, and then you come back, then you do a pi transfer, then you crank up again. So there's a lot of inclined time in this, and when it comes
From an infinite number of possibilities, the tours are whittled down to 9. Next, the science teams are to rank them as green, acceptable, yellow, partially acceptable, or red, not acceptable.
But it sounds like 6, H9, and 8 should either both be red or both be yellow.
But wanting more wiggle room, scientists introduce a new color to the voting: lime.
Okay. 6H9, 3 greens, a lime, and a red.
I mean, it's kind of like our job was over. We're just waiting to hear the result. I mean, I guess it's kind of like the jury coming in, but you're too tired to care what your sentence is.
So you're talking about PF9 for Titan?
Eventually, a consensus is reached.
Applause.
No doubt the winning tour has left the scientists equally happy and unhappy. The tour designers are just plain happy. For the first time in a year, they will have their lives back.
It's done. It's over. The decision's been made. You know, we were happy, but also just absolutely felt like your truck had run over you.
Hello, this is Arthur Clarke, joining you from my home in Colombo, Sri Lanka. I'm delighted to be part of this event to mark Cassini's flyby of Iapetus.
When science fiction writer Arthur C. Clarke wrote the classic 2001 A Space Odyssey, he chose for the book's final scene Saturn's moon Iapetus.
As you know, I have more than a passing interest in Saturn. And I was
In the movie version of 2001, the ending scene was changed to Jupiter, but for Clarke, Iapetus remained a place of deep mystery. He shared his enthusiasm for Saturn's third-largest moon with those who gathered in JPL's auditorium to witness images of Iapetus as they first arrived.
This is a particularly exciting moment for fans of 2001, A Space Odyssey, because that's where the lone astronaut, Dave Bowman, discovers the Saturn monolith, which turns out to be a gateway to the stars. More than 40 years later, I can't remember why I placed the Saturn monolith on Iapetus, but I've always had this strange fascination for Saturn and its family of moons. By the way, that family has been growing at a very impressive rate. When Cassini was launched, we knew of only 18 moons. I understand it's now 60 and counting. I can't resist the temptation to say, my God, it's full of moons. So I'm going to keep my fingers crossed with what Cassini discovers at Iapetus. I want to thank everyone associated with this mission. Science projects are tremendously important for our understanding of the solar system. Who knows, one day our survival on Earth may depend on what we discover out there. This is Arthur Clarke, wishing you a successful flyby.
What Cassini saw at Iapetus was breathtaking. Many of the observations focused on examining a mountain ridge on the equator that contributes to the moon's unusual walnut-shaped appearance. These mountains, made mostly of ice, are among the tallest in the solar system, soaring 12 miles high, more than twice that of Mount Everest. Scientists have more than one idea as to how they may have formed.
One thought is that perhaps when Iapetus was more fluid or pliable, it was spinning very, very fast. And so it sort of bulged out at its equator as it was spinning, and as it cooled off, then it held that shape, actually had that mountain range going around it.
While the bulge remains to be solved, scientists believe they are on more solid ground as to the reason why Iapetus is so starkly black and white.
One of the puzzles going all the way back to Voyager is that dark material coming from inside Iapetus, maybe some kind of volcanic eruption, or is it coming from outside? And Cassini solved that puzzle. Turns out that there's a captured moon, Phoebe, in the outer part of the Saturn system. Dust from Phoebe comes in and it gets swept up onto one side of Iapetus, coating that side in almost a charcoal black material.
This black material absorbs heat from the sun, turning the moon's water ice into a vapor that accumulates like snow, falling on the trailing side of Iapetus. The result is the moon's distinct yin and yang veneer. Phoebe, the moon responsible for Iapetus' dark material, resides on the outskirts of the Saturnian system. This is a frozen artifact from the time when the solar system was forming. Its battered surface speaks of a violent past. Everywhere there are ancient craters and landslides. Phoebe was the first Saturnian moon Cassini saw up close, and it proved to be a harbinger of the bounty to come. For at the time of Cassini's launch, there were just 18 confirmed Saturnian moons. Now, there are 82. These moons are as diverse in shape, size, and composition as they are numerous. Battered Mimas, with its massive crater, resembles the Death Star from Star Wars. Hyperion resembles a sponge. Its interior is full of voids, so much so that it's thought of more as a rubble pile than a solid body. Atlas could be mistaken for a UFO. Prometheus a potato, and Pan a ravioli. These and other moons are part of Saturn's intricate system that influences the rings, the magnetosphere, and even the planet. And while best known for its rings, Saturn is deserving of its own attention. It is the second largest planet in the solar system. In volume, Saturn could hold more than 700 Earths. Composed mostly of helium and hydrogen gases, the planet has no solid surface, although deep within there is thought to be a dense core of metals. Despite its size, Saturn is astonishingly light, less dense than water. If it could be placed in an imaginary giant bathtub, Saturn would float. The planet's spin rate is also impressive. A Saturn day is only 10.5 hours long. This rapid rotation causes the planet to bulge out at the equator and flatten at the poles. Saturn's butterscotch exterior appears bland and calm, but this appearance is deceiving. Beneath the cloud tops is a churning cauldron of lightning and wind speeds that can reach over 1,000 miles an hour. And about every 30 Earth years, Saturn experiences a megastorm. Cassini had the good timing to witness one. This raging storm would grow to encircle the entire planet. Even more amazing is what can be seen at Saturn's poles.
Saturn has something unique in the solar system. It has a hexagon circling the North Pole. It's a 6-sided jet stream. You can almost imagine horses on a racetrack racing around the hexagon. We don't know why it keeps its 6-sided shape. It's some kind of a wave pattern that goes around Saturn, but it's very stable. It's been there for decades. It's about 2 Earth diameters across. At the very center, right at the North Pole, there's a giant hurricane. It's about half the size of the continental United States, with wind speeds about 4 times a typical hurricane force wind.
A second monster storm was discovered at Saturn's south pole. It is also ringed with towering clouds, but lacks a hexagon. And while this vortex looks like a hurricane, it doesn't behave like one. These are just some of the wonders of Saturn witnessed by Cassini. But still to come is an entirely different way to explore the planet as the spacecraft nears its end. By 2017, Cassini had circled Saturn more than 250 times, and the mission's achievements had earned the praise of many, including the first human ever to set foot on another celestial body.
Hi, I'm Neil Armstrong. We're here at the Cincinnati Observatory.
Armstrong recorded this message to the Cassini team 4 years before his passing.
It has been said, science is about what is, and engineering is about what can be. The Cassini-Huygens program has demonstrated the best of both. And you are the people who made it the enormous success that it has been and is. Some of you are in science of what is, unraveling the secrets of the Saturnian system. Someone's had a full-time job just counting moons. The number of your new discoveries is nothing short of amazing. Some of you were in the what can be category. You were involved in the design of the spacecraft and the trajectories, system design and operation, instrumentation, how to make the measurements, programming the computers. we all give you our very best wishes to continue your outstanding performance. Congratulations to each and every one of you.
Cassini's original lifetime warranty was for 4 years at Saturn. The mission more than doubled that guarantee. In 2017, 20 years after its launch, the spacecraft was still performing beyond expectations.
It's like the spacecraft just now broke in. Everything's working just perfectly.
Yet Cassini's days are now numbered. It is running out of fuel. And before that happens, the spacecraft has to be set on a course that will ensure it will not crash into one of Saturn's moons that might harbor life.
Given that Enceladus now appears to have all the ingredients that could harbor life, we have new rules. And frankly, we have a very nice home for microbes. It's room temperature inside the spacecraft. A hardy microbe could easily have hitched a ride along. We went through a lot of studies on disposal options for the spacecraft. Some of them were to take it into a very long loopy orbits of Saturn, where it would be stable for thousands of years. But the scientific benefit wasn't there. We also had options to go back to Jupiter, go out to Uranus, go to the Trojan asteroids. We could have exercised a lot of those options, but none of them had the strength and appeal of a scientific mission at Saturn. We were built for Saturn. Saturn was absolutely just bristling with things we hadn't yet explored. Once we chose to stay, we had to figure out how to dispose of the spacecraft cleanly.
It's decided to end the mission by plunging Cassini into Saturn, but not before attempting to dive 22 times between the planet and the rings, a place no spacecraft has ever been.
This is where Cassini is right now in its orbit of Saturn. It's below the ring plane, which goes out here. We'll come over the top of the rings again in a few days. We do this every 7.5 days. On April 22nd, the spacecraft will fly fairly close to Saturn's big moon Titan. And Titan has enough gravitation that we can use it to trade orbital momentum between Titan going around Saturn and the spacecraft going around Saturn. And with that trade-off, a marvelous thing happens. The orbit of the spacecraft jumps inward towards Saturn so that the next close flyby of Saturn will be in between the rings and Saturn's atmosphere. Is that dangerous? We don't really know, but who knows? We might run into some big ring particles in there that we can't see in our observations. If that happens, oh well, it's been a good mission. If it doesn't clobber the spacecraft right away, then we'll have 22 more flights through, all the way out 1 million miles. It's a 1 million mile high roller coaster. Picture yourself going click, 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 click up a huge roller coaster. And then starting in, it's just falling. As we whip through the space between the rings and planet, we'll be going 120,000 kilometers per hour. The most important thing, I think, is the moment when Cassini's signal reaches the Earth. That means that the spacecraft has gone through, I don't know, maybe 1,000 different commands, turning the spacecraft, operating the cameras and spectrometers and dust detectors and magnetometer. They make their observation. The spacecraft keeps turning and twisting to point everything. And the moment the signal hits Earth, we know that all of that in the past day has been successful. And I think that's party time.
But before there can be party time, there's the less glamorous work of creating those commands, and sometimes testing them in tucked-away labs.
I think we're good to go.
Well, this is another C kernel. So after this meeting, I'm going to have to switch out this C kernel for 467. This is 444.
Okay.
And this won't run in real time because it's synced up to the real spacecraft clock. So we're just going to leave it sitting there so it's got a reminder of when the first command is.
Right. So the first AACS command is at 10:52:38. Yeah, this is interesting.
What we're setting up is we're practicing a main engine maneuver. We could need in the last few weeks of the mission to either come up out of the atmosphere or go down into the atmosphere. So actually we're just simulating about a 1 meter per second main engine burn. So the engine's going to burn for how many seconds?
I'm not sure actually.
4 or 5 seconds?
Do you remember?
Jody?
Jody, how long does the burn last? On 1 meter?
About 6 seconds.
6. Okay. And what the spacecraft does is the spacecraft always starts from Earth point, and it does a roll, and then it does a yaw, and then you'll unyaw, and then unwind, and come back to Earth point, and then relay all the data back down to Earth. We'll be able, because we're in the integrated test lab, we'll be able to see all the data in real time. So we're actually going to call it out in real time since we're practicing it.
What does SWAMBO stand for?
It stands for She Who Always Must Be Obeyed.
It should take about 29 minutes.
So here it is. Wind yaw turn. And they're calling something out right now.
Systems?
Systems.
Systems. The wind roll turn is complete. The reaction wheels have powered off.
Oh, there it is.
Up, here we go. Hey, attitude control.
You weren't listening.
Nope. I
They said-
wasn't listening.
They said it.
Okay.
Tina called it out.
Tina, I can't hear you.
I'm sorry.
You and Masasha are going to have to speak up. You're going to have to develop your Julie voice.
She was literally just saying the words, "Oh, I have to announce," when you said, "Call out the burn status."
It is now more than a month later. All of the testing of commands is over. And on this evening, team members and their families and friends have gathered to see if Cassini will survive its first plunge between the rings and Saturn. The event has been given a name, Gateway to the Grand Finale.
Well, I just want to welcome everyone to our Gateway to Cassini's Grand Finale. And this is a Cassini family event, and I'm so happy to see so many people here to share in what's about to happen tonight.
In 1990, Linda Spilker stood on this same stage speaking of Saturn's rings.
Saturn's rings are more transitory elements of the
Now,
solar
3
system.
decades later, she is Cassini's project scientist and this evening's master of ceremonies.
So at midnight tonight will be the first time Cassini turns back to the Earth, sends a signal, and lets us know that it successfully navigated through this gap where it's flown for the very, very first time. So we have a lot in store. It'll be very exciting.
While awaiting news at midnight, updates are given on Cassini's latest science discoveries, and a time-honored JPL ritual is acknowledged.
Now, I'm not particularly superstitious, but you know there's a long-standing JPL tradition. So last night, I went out and I decided we needed to have some lucky peanuts, just in case. And I thought about it some more and I thought, maybe we need 2 jars of lucky peanuts. And with that, I'd like to introduce the Cassini Virtual Singers. The Virtual Singers really take the heart and the soul of Cassini and capture it with music. So, tonight, live from JPL in Pasadena, California, just back from their multi-world tour, we now have the Cassini Virtual Singers.
Cassini flies over the oceans. Cassini flies over the seas. Cassini flies through the ring.
As the Cassini singers take their bows, flight team members slip away to take up their positions on console in mission control.
I-ready 5 by also. Power, voice check on FSO cord.
I-ready 5 by 5, OB.
I-ready 5 by also.
Yes, sir. Two notes past long.
Check on FSO cord.
I-ready 5 by 5.
I-ready 5 by also. Flight Director and Project Manager, I'd like to announce at this time that all stations are ready to support. Copy it.
Copy that. Thank you.
Okay, what we're looking at here is the mission support area, and they each have their various stations looking at different aspects of the spacecraft, and they just went through a check to make sure that everyone can hear everyone else in the MSA, and we also have sound into that room as well. So Eric, do you want to talk about what we're seeing on the screen over here?
Yeah, so on the left, that is the signal that Deep Space Network is currently detecting, which is nothing. It's just a flat noise signal right now. But what we're all going to be looking for here is for a spike to pop up out of that noise. And when we see that spike, it means that we're receiving a signal from Cassini.
We have X-band carrier signal detection in the Orbital receiver.
That's a nice booming signal. So the carrier signal is there. We'll have to wait a few more minutes until that we'll see if there's actual data flowing. But this is a great sign. Woo!
Receiving back Cassini's carrier tone means the spacecraft has survived the first dive.
Signal just came booming through right on time. Couldn't have been better.
Along with feelings of relief is the hope that science data will soon begin to flow. But now comes a moment of confusion. How to best listen for Cassini's signal.
SCO Systems, Cassini-Huygens, the station is currently looking for the X-band one-way carrier signal, and they're also going to attempt to lock up to the 1896 rate, so stand by one, I'll let you know if they get it.
A-Systems Flight Director, don't have them lock up on the 1896.
Okay, you just wanted to look for carrier? And SCO Systems, Cassini-Huygens, the station has locked up to the X-band one-way signal at neg 140 dB, which is expected for the 1896 rate.
No.
Copy.
SCO Systems, this is NAV.
Nav, go ahead.
We're seeing a one-way Doppler signature.
Copy.
The moment of uncertainty ends as quickly as it began, and Cassini begins transmitting its science data sooner than expected.
Flight Director on net. Well, we're waiting for 12:05, but it looks like we're early.
Playback is locked.
Copy.
Well, if there's any more questions, I'd be happy to take questions. I mean, this is the big moment that we waited for. And it's here, and it's every bit as good as we had hoped.
We're okay for 22 weeks. We're okay now.
The spacecraft went through the ring plane just clean as can be. There were no indications of fault protection. Telemetry data playback is exactly where it's supposed to be. we can all go home. We don't have to spend all night fixing everything up. The spacecraft's in perfect shape.
System lead, this is ACS. ACS, go ahead. The downlink roll has started. At this time, we would like to report that all the initial conditions checked out. Initial attitude and wheel speeds look good. All instruments are on. The star tracker is tracking 5 stars, so that looks good. Both sun sensors A and B are both on, so they match each other's telemetry at this time. We're waiting for the roll to give us a full quadrant checkout for the rest of the pass. Other than that, ACS looks great. Copy. Flight Director and Project Manager, this is Systems Lead. All subsystems have reported in, including the SIP lead at this time, and everything is nominal.
Congratulations, everyone.
Copy. Copy.
Hello everyone, I'm Ye Hill and welcome to NASA's Jet Propulsion Laboratory. After 2 decades in space, NASA's Cassini spacecraft reached the end of its remarkable journey of exploration. Today, the spacecraft made its final approach to the giant planet and plunged into the Saturn's upper atmosphere, ending this extraordinary mission. But due to the vast distance between Earth and
the Cassini mission has actually not ended. Not yet. The grand finale event is still a week away. This is a rehearsal.
The sun isn't up yet, and more than 1,500 Cassini scientists, engineers, alumni, their friends and family have gathered in Mission Control here, Von Karman Auditorium at JPL, Beckman Auditorium at Caltech.
What's true for engineers is also true for JPL's public communications team. A little pre-planning to work out the kinks can be worth its weight in gold.
Australia, it's 4 a.m. here in California. The loss of signal really happened at about 3:30 Pacific time, a half hour ago. Why is the team here?
We thought it'd be over.
We will be checking back with you in just a couple of more minutes. There is a huge crowd at Beckman Auditorium at Caltech right now. Cassini science team member Morgan Cable is there. Morgan, what is it like out there?
Hi, Gay. This is Morgan here at Caltech, and the atmosphere is electric.
I believe we're going to a bumper. And I'm one of those hoping that Cassini will hang in there and fight for the very last seconds of data.
What's going on?
Well, we've just got the word that Cassini has given us its last bit of data. The room is celebrating, lots of hugs going on, a few tears.
With me now is NASA Director of Planetary Science, Jim Green. Jim, thanks for joining us.
You know, Gay, this really has been a historic mission.
Before we do that, let's take a moment to chat with JPL Director Mike Watkins. What's your feeling about the success of the Cassini mission?
You know, I could not be more proud about the role that we've had in this mission.
With me now is Alvaro Jimenez, the ESA Director, and the Director of Science, ESA Director of Science, Roberto Batiston.
But all kidding aside, the planning paid off. For the elaborate multimedia and interactive coverage of Cassini's grand finale would be watched by millions.
And the Emmy goes to NASA JPL Cassini's grand finale.
And earn JPL its first ever Emmy.
I got to thank the stars that made a bunch of geeky rocket scientists, rocket engineers and scientists into rock stars.
Here's the Huygens image of the gullies.
Less than a week remains before Cassini's end, and team members from around the world are arriving to take part in the grand finale. This is the final meeting of the Science Radar Group.
So we've actually been at this for 40 years. This is an image from 1976. It's one of Bruce Murray's Purple Pigeon projects. And here's what became the Huygens probe, beaming the data to Cassini, which is flying by. So that far in time, and I want to make a caveat.
As they meet, 1 billion miles away, Cassini is flying by Titan for the last time.
Right now, Cassini is flying close to Titan, 74,000 miles away. And Titan's gravity has given Cassini its final push, its goodbye kiss, and its fate is sealed. Wow. And toast to great spacecraft, a wonderful mission, and our final pass by Titan. I worked on the Cassini mission for over 30 years, and that's the time it takes Saturn to circle the sun a single time. And when you work on a mission for that long of a time, and when you work for people, many of whom stayed and were there as long as I was, you really start to feel like family. You get to know each other, you take vacations together, you attend meetings together, you see your families grow up together. And then when the mission ends, it's hard because you know you'll keep in touch with this family, these people who feel like friends, and yet you also know you'll go your separate ways.
So for the people who have been with the team from the beginning, thank you, and I hope you found this. You are now 30 years wiser and smarter, and this has been a great experience. But for the people who joined later, hopefully you found that also a great stepping stone and great experience for you guys to lead the future of planetary exploration. So thank you again.
Cheers.
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 Where are the cookies?
The next day, Cassini engineers gather for their last in-flight operations meeting.
5502 is when we predict to hit 100% duty cycle, and AACS predicts loss of signal 12 seconds after that.
Navigation, Dwayne.
As of yesterday at about 1:30 in the afternoon, we had our last Titan 5i, and we're on our way into Saturn now.
DSN, Mike.
So we had 7 passes last week, 14 command files, including the last set of built. So we have no more commanding for real time.
S101, Jan.
Okay, the spacecraft's basically nominal. We have no new ISAs, no other errors. And then basically we've got the end of the sequence. We're just clocking out.
Here we are knowing that this is the end is very sad. But knowing in a mission like Cassini, where we had an ending date, we had a sequence of events to follow, gave us some purpose.
All the team stepped up. I'm very grateful for all your support, and I just want to say thank you.
Does anyone else have anything?
Yeah. Just because everyone else has piled on with the thank yous, you here and in the room and out on the phone have rocked the world. And this is our last meeting with the spacecraft, but it has just been an incredible ride. I am very, very proud to have been associated with all of you. And as an incentive for next meeting, when we don't have a spacecraft, we will bring donuts.
Thanks, everyone.
I know you already told me. There's 2 hours.
2 hours.
2 hours.
2 hours to count.
Yep. It is now 2:55 in the morning in California. We've got about 2 hours to go till the end. Science data on the recorders is done. We're currently in our real-time plunge configuration. So everything now is essentially real-time data from the instruments as we go into the planet. The FFTs will begin to fade and decrease, and then at just one point they'll just disappear entirely, and that'll be the end. That'll be the end.
It's really hard to end the mission this way. This one's been my companion, constant companion for 22 years. My job has always been take care of the spacecraft. Everything's working just perfectly. I mean, you have to recognize the fact that we're out of propellants, but I have no idea how I'm going to feel.
Well, this is my screen up here. So this screen here is the last 10 minutes of the one up at the top. The one at the top is kind of the big picture. And this one has atmosphere model. This is also the last 10 minutes, but this one does not have atmosphere model. So what we're hoping to see when we get to the very end and get into the atmosphere is this one's going to start being different from this one. Right now they look very similar. Once this one starts changing from this one, then we know that we're in the atmosphere and we're experiencing drag on the spacecraft.
About a minute before loss of signal. The other spot we've got over there, the attitude control system, those charts on the right of that screen are showing thruster activity, and we're going to watch those just go right up the wall, so to speak. And again, for about a minute. I mean, everything happens so fast right now.
Okay. So what we're seeing is each of these little places where the curve turns around is where the thrusters are firing. We're trying to control the orientation of the spacecraft, and every time we see a little change of direction, that's a thruster pulse. And those pulses are getting more and more frequent, and the reason for that is we're getting closer to Saturn, and its gravity gradient is starting to rotate the spacecraft around. What's going to happen is eventually, instead of bouncing slowly along the edge, it's just going to be sitting right on the edge, firing the thrusters continuously, all the way up to the point where the thrusters are on fully and it can no longer maintain that attitude, and then we'll just drift outside of our thresholds, and then we'll be tumbling. That will be the end of it.
When do we want to tear up the ceremonial anomaly plan?
RQ.
If you think of Cassini as a symphony, this is the final movement. There's so many emotions. I mean, it's such a great, sweet ride it's been. It's been a triumph. We are a village. It has been a phenomenal teamwork. We finish each other's sentences, we tie each other's shoes. It is absolutely going to be something that I will never be able to recreate, and I will miss it greatly.
Among those arriving is Mike Watkins.
These were not always at 3 a.m. and 5 a.m., right?
Were you able to get any sleep before this?
A couple hours, a little bit.
Watkins is 1 year into leading JPL. The fourth JPL director Cassini has seen.
Hello everyone, I'm Gay Hill, and welcome to NASA's Jet Propulsion Laboratory. After 2 decades in space, the Cassini spacecraft has reached the end of its journey at Saturn. The spacecraft made its final approach to the giant planet. Meanwhile, it is 4 a.m. here in California. The sun is not up yet, and more than 1,500 Cassini scientists, engineers, alumni, friends, and family have gathered for this moment. How does it feel, Todd, to be here?
Hi, Gay. Well, it's great to be back. As you and I sat there in 2004, we never dreamt we'd be here in 2017 still talking about Cassini and collecting science data. So I'm just thrilled to be here, even having aged some years since SOI.
Flight Director Systems Lead.
Go ahead.
All subsystems are nominal. We are go for Final Plunge.
Copy.
It's one.
The spacecraft has just crossed 40 degrees north latitude. Copy, thank you.
The trajectory is the very latest trajectory that we've reconstructed with the latest data that we could get. So that little dot here, that's Cassini. So it's pretty accurate. And yeah, looks cool.
Systems Lead, mission planning.
There you go.
Go ahead, mission planning. Spacecraft has just crossed 30 degrees north latitude. Altitude is 6,000 miles. Copy, thank you.
Miles.
Yeah, fun to calling out miles, that's weird.
Yeah.
Yes, we usually don't use them.
We never use that.
Well, we are a little over 10 minutes away from the loss of signal, so we will be focusing our attention to the control room very soon now. But before we do, let's take a moment to chat with JPL Director Mike Watkins. So, Mike, how are you feeling?
Well, first, good morning.
Yes, very early morning.
We always tend to do these events somehow at 3 in the morning or 5 in the morning.
Why did we do that?
But, you know, it's kind of a bittersweet event for all of us, I think. For me personally, it's more sweet than bitter because Cassini's been such a fantastic mission. But I think, you know, one of the important things about these events is to celebrate the incredible hard work, the decades of hard work of the team that designed, built, and operated Cassini. And that's really, right, the heart of the spacecraft is really the people that worked on it and the people that have been operating it. And this is a great time to celebrate that level of dedication, that devotion, you know, to work on something for 10, 20, 30 years. That's sort of unparalleled in human history.
Systems, this is ACS-1. Go ahead, ACS. We're still waiting for a transition to high rate mode, but it looks like we're going to start accumulating thruster on time at a higher rate now, and our attitude control error is starting to be more active. Okay. And we are in the atmosphere. Copy, thank you.
Oh yeah, there. Now we're really going off. That's it. Spacecraft hanging in there. Yeah.
Flight Director, ready science. We have lots of signal at X-ray band and Sierra band.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal 115546 for the S-band, so that would be the end of the spacecraft.
Project Manager on FSO Quad. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project Manager off the net. Take the first 3 more seconds. We will have 4335 and 74 Cassini-Huygens. 4335.
My feeling was I want to hug somebody and share saying goodbye. And that was hard. It was hard to say goodbye.
And 74, if you're listening, Project Manager, Program Manager is confirmed end of mission at 115546. This concludes Cassini's 13-year exploration of the Saturn system.
The looks that you see on people's faces, we're not acting. We felt that. You're looking at raw emotion at that point. I thought I was going to be okay, and I wasn't. We did it, and it worked, but it's over. Now what?
Doing this long time.
Yeah. Let's do another one.
Yeah, let's do another one.
Maneuver lead, this is ACS.
ACS, go ahead.
The post-burn unwind roll turn is complete.
Copy, thanks.
FSO court.
Flight director, go ahead.
Yeah, you can go ahead and check people off net. We'll debrief everybody in here on the net, and we'll walk through what we need to do, including what happens with the DTUs.
Okay, copy, got it, thank you.
Maneuver lead, this is thermal.
Thermal, go ahead.
The thermal devices subsystem is nominal following the maneuver. Requesting permission to go off the net.
Copy, sounds good. Thanks for your support.
Copy that.
Tom, go ahead.
Yeah, I'd like to report that telecom is nominal, the subsystem is nominal, and the Doppler and telemetry look good, so we would request to sign off the net.
Copy, sounds good. Thanks for your support. CDS, go ahead.
Yeah, we note that the CDS system is nominal at this time, and we'd like to sign off the net.
Okay, copy. Thanks for your support.
Power is nominal, and I'd like to request permission to get off the net.
Copy, thanks, Tower. Maneuver lead, system full protection. SFP, go ahead. I can confirm no fall protection activity, and all telemetry is per predict as of page 10 on the procedure, and SFP would like permission to go off net. Okay, copy, thank you.
Final status for the OTM on our side is about 1 sigma off. Request for signing off.
Okay, copy, thank you.
Commands in the maneuver, and done my final queries, and it looks like a nominal burn. So I'm requesting permission to sign off the net.
Okay, copy. Thanks for your support.
Maneuver lead prop.
Prop, go ahead.
Burn time was nailed within about half a second, so it looks like a good RCS burn with respect to prop.
Ace, maneuver lead on FSO cord.
Maneuver lead, Ace.
Yes, at this time all subsystems have reported a nominal burn for OTM 469, so I will be signing off as systems lead.
Copy that, thank you.
Thank you.